Your boss sends you a table like this: revenue by region, with years spread across the columns. It's easy to read, it makes sense in a spreadsheet, but the moment you try to plot it or run analysis, your code needs to look like this, where region, year, and revenue each have their own column. The transformation from the first format to the second takes a single Polars expression, and that's what we'll learn today. The difference between wide and long data formats can trip up a lot of people, and it's one of the hardest things to describe to an AI tool without the right vocabulary. Work through the examples in this video, and you'll understand how the long data format can be used in data analysis. We'll also start creating new columns from existing data. Feature engineering. By the end of this video, you'll be able to reshape any table and add computed columns on the fly. So let's get started. This video builds on the first 5 in the series, covering Python installation, virtual environments, Jupyter Lab, pandas, and polars. If you need to catch up on any of those, links are in the description. As before, navigate to your project folder and activate your virtual environment. With our virtual environment active, let's launch Jupyter Lab. In Jupyter Lab, create a new notebook by clicking on the Python tile on the launcher. Then right-click on the tab and rename it to something like Working with Data. Let's build the table from the intro. We're starting with a pandas data frame, as it's still the most common format you'll encounter in the Python ecosystem. We could just as easily start with a polars data frame, and we'll use polars to reshape the data below. Now let's take a look at it. This table is in a wide format that is easily readable, but there's a hidden problem. The column headers, 2020, 2021, and so on, are actually data values, not variable names. There's no single column for year that you could use in a plot or include in a formula. And notice the numbers in the table are revenue figures, but there's no column label revenue. The tidy data framework, introduced by Hedley Wickham, gives us 3 simple rules. Each variable forms a column, each observation forms a row, and each cell contains a single value. When data follows these rules, it's in a long format, and it works naturally with analysis and visualization tools. Let's transform this wide table into a long format using polars. The method is called unpivot. Here, I'll create a new data frame, long_format_df. First, I'll convert my pandas data frame to a polars data frame, and then use the unpivot method. At a minimum, you'll need 3 arguments. You need to identify the index, and then assign names for both the variables and the values. Let's see what we get. Let's look at what happened. We went from 4 rows and 6 columns to 20 rows and 3 columns. The year values that were column headers are now in their own column called fiscal year. The revenue numbers have their own column called revenue, and we can identify the units here, millions. Region repeats itself for each year. The index argument tells polars which column to keep as is. Region stays put. Everything else gets unpivoted. The variable name, the value name, these arguments let us give meaningful names to the new columns. In pandas, the equivalent method is called melt. Same concept, different name. If you need to go the other direction, long to wide, polars provides the pivot method. We can take our long format, use the pivot method, and again, we need a minimum of 3 arguments, on index, and values. We're back to the original shape. The on argument specifies which column values become new column headers. You'll typically use unpivot more than pivot, but knowing how to convert between these two table shapes is important as you move between data analysis and creating summary tables. Feature engineering means creating new columns from existing data. Let's start with a new pandas data frame using sales data. We can view the data frame. We have units and total revenue, but what if we want to know the average selling price per unit? The most direct way to add a column in pandas is bracket assignment. And we can see the result. This is pretty simple. We divide two columns, multiply by 1,000, and assign the result to a new column name. Notice I used copy first. Without it, we'd be modifying the original sales_df data frame directly, which can often lead to surprises. An alternative approach is the assign method, which creates a new data frame without changing the original. And again, we can confirm the results. The lambda function here is a compact way to define a calculation in line. Notice we chain rename because Python doesn't allow spaces or parentheses in keyword arguments. So we name it ASP first and then rename it. For conditional logic, we can use the numpy where function, and we can create a new column that indicates whether the ASP met a target of, say, $940,000. Again, let's view the results. So all this works, but notice how many steps we needed. I feel Polar simplifies all this with a single readable expression syntax. So let's see how. In Polars, we use with columns to add new columns. First, let's convert our pandas sales data frame to Polars. And take a quick look. To create the ASP column, we use the Polar expression inside with columns. And we can see this has added a new column. We can read this aloud with new column that is total revenue divided by units times 1,000, named ASP thousands. Again, the alias method lets us name the new column as part of the expression. For conditional logic, Polars has a when, then, otherwise construct, which reads almost like a sentence. Let's add the same met goal column. Here, I'm using the Polar expression when greater than or equal to 940. Then, if it met it, yes. If it didn't, no. And I've assigned the alias as met goal. When we compare this to the numpy where in pandas, the Polar expression is longer, but each piece, the condition, the true value, the false value, is labeled. The pl.lit wraps a constant value, yes, no, as a Polar's literal. And this is how we handle strings. We covered a lot of ground here. You now know how to reshape data between wide and long formats using unpivot and pivot, and how to create new columns in both pandas and Polars. These are the transformation tools you'll reach for most often. In the next video, we'll tackle the messy side of real-world data, missing values, incorrect data types, and how to turn a raw data frame into a polished, presentable table. If you're finding this series helpful, subscribe to the channel for more content on how business and marketing professionals can use Python to enhance and automate complex analysis in their everyday work. And if you want to go deeper on any of these topics, check out the companion book, Getting Started with Python on Windows 11. The links are in the description. So save your notebook, and we'll continue in the next video.